Okay, we're recording now. Let's see. Use the first graph to graph the function g of x equals f of x minus 3 minus 1. What we're going to do is take these 2 points and shift them based on what this tells us to do. Remember, this is always going to be the opposite in here, and this is going to be the same out there. So this tells us to take this point and all of these points and first shift them plus 3 on the x-axis. So this point right here is going to go boom, 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 shifting 3 on the x-axis, a plus 3, because always when it's attached to the x, you do its opposite, and then a minus 1. So that point comes down here, and all of these points shift also. It's just easiest to grab 2 actual points. This one, same thing, positive 3 on the x-axis, and then minus 1 on the y-axis. And there's the new shape right there. This guy shifted to match that. Okay, use the graph of x squared. So you have to know what x squared looks like. The good news is you actually don't, because this is a multiple choice test, and they're not tricking you by putting in these other graphs. All of your choices will be parabola graphs for this one. So we're asked to graph it based on those changes. Remember, we've got a pattern here. H serve. H is the horizontal shift. That's the sideways shift on the x-axis. S is stretching. And we won't have any stretching on your test. You don't see any stretching in here, any number, any coefficient in front. You won't have any of that. Reflection, you will have one reflection on your review, one reflection on your MyMathLab review. And so you know you're going to have one reflection on your test. And then vertical shift. So what you want to do is do them in this order. Mostly we're just doing horizontal then vertical, so no big deal. So we'll pay more attention to H serve on number 3, but for number 2, we're just going to look at the x change and the y change. So you know that x squared is a parabola, and we've got a shift going on of -1, -4. So the new vertex, instead of being at 0, 0, will be at -1, -4. Remember, you're always doing the opposite of that, the same as back there. So -1, -4 will be our new vertex. Let me just sloppy graph up. -1, -4 is down there somewhere. And then you just draw in the parabola. So you'd expect it to look like that. You're not going to have super picky ones. They'll be in that one or going upside down. You know, you have to know how to find the vertex and then draw it in, and it'll be multiple choice. Okay, number 3, use the graph of the square root of x. The square root of x, to remind you, looks like a shoulder. It's that one. And we are graphing h of x, which has 2 changes. It has a horizontal change. The horizontal change tells you to go +2 on the x-axis. So we would move over +2 on the x-axis. Boom, boom, like right to there, and draw it like that. There is no stretch. Remember, I told you we wouldn't have any stretches on your test. There is a reflection, though, so you're going to need to reflect it next. So we would move it down. Let me do another color pen. We would flip it over the x-axis, so it would look like that. And then is there a vertical shift on it? No, there is no vertical up or down shift. You have to do it in this order. You have to do the reflecting before you do the vertical shift. So that if we'd had let's say we'd had a +1 out there, then we would take this and move this up 1, and then that would be the final, but we didn't have a vertical shift on that. You have to do the reflecting before you do the vertical. So H serve is what I was calling it. You just have to remember that your order needs to be x, reflect, vertical. Okay, let's look at number 4. Use the graph of the absolute value of x. The absolute value of x is a v. Looks like that. And its vertex point is 0, 0. What are we doing here? We're involving horizontal shift and vertical shift, so we don't have to worry about order so much. We can just worry about the vertex. The new vertex point will be the opposite of that, -3, and the same as that. So the new vertex point for this will be at -3, -5, somewhere down there maybe. Maybe it's scooted over a little bit, but you get the idea. -3, and then down here at -5, and that will be the new figure. And again, this is a gift to you with its being multiple choice and them not being super sneaky. You don't have to worry about what does this shape look like, because all of the multiple choices will be the absolute value figure. They're assuming that you understand that part of it. So no need to really super duper memorize those. Number 5, graph of x to the third. That's a snake and a snake charmer snake like that. To graph h of x equals x to the third plus 4. Let's do the same thing. We've got no horizontal shift at all. So the new vertex is going to be 0. There isn't a number between the x and the cube like there was here, so we did -3. Like there was here, so we did +2. There is no number, so there is no shift on the x-axis. But there is a shift on the y-axis. 0, 4 is our new vertex. So there's the snake charmer. If we are going to move it to 0, 4, we're going to move its vertex point to 0, 4. Up here, it's going to do something like that. Its belly button is going to shift up 4. All right, next two problems are domain problems. The thing that you need to remember is that denominators cannot be 0, and radicals have got to be 0 or greater. They cannot be negative. So let's look at these two problems separately. If we're worried about x squared minus 4x minus 5 cannot equal 0, then we'll factor this. Cannot equal 0. X and x, the signs need to be different. We need two numbers that multiply to give us 5, whose difference is 4. Of course, that's 5 and 1. And of our two choices, in order to get a -4, if you're going to add them, you need a -5 and a +1. So only put the 5 there and the 1 there. Set each piece equal to 0. Can't equal 0. Can't equal 0. So x can't equal 5, and x can't equal -1. You've got to write this in interval notation, I believe. So -1 is right there. 5 is right there. You need this stuff out here. You need the stuff between there. You need the stuff on the left. You can't include -1. You can't include 5. Otherwise, you'll zero out this bottom, and that's what you can't do. So you'll have the domain here will be -∞ to -1. Union, we need this gap in here between -1 and 5. Union, this piece out here, 5 all the way to infinity. So those three in a choo-choo train. Remember, the answers are back here. See, that was number 6 right here. Same thing. So the answers are back here if you need reference for them. Okay, number 7 is the same idea, except that we've got a radical and it's in the denominator. Not going to be a problem with it being in the denominator, but it is a radical. So let's see what we've got here. On this first one, I gave you 2 here because I want to have the practice of it. G of x equals 1 over the square root of x minus 3. So you need to keep x minus 3 greater than or equal to 0. What's under here can be 0. Square root of 0 is a 0. Oh, that's the problem here. So putting this in the denominator creates an extra effect. So it's got to be, you know that in a radical, it's got to be greater than 0 or equal to 0. But the fact that it's in the denominator, it cannot be equal to 0. So this is not going to be a good setup for that. Because we have both of our two issues happening in this function. We've got both the denominator, can't equal 0, and we've got a radical, it's got to be greater than 0. Our new setup looks like that. We have to accommodate both of the problems with domain. There are other problems with domain, but college algebra doesn't get into either of those. So x has got to be greater than 3. On a number line, it's going to look like that, and you are going that away. Arrow points you that way. So 3 to infinity is what we're talking about. Let me make sure that I caught that when I was doing this problem. Oh yeah, I did. Okay, so we've got 3 to infinity there. 6's final answer not have brackets. Question 6's final does not have brackets because let's put a bracket right there at 5. That means you can include 5. So let's put a 5 there. That'll give you 25 minus 20 minus 5, and that equals 0. And that's exactly what you're trying to avoid. You don't want to have a 0 in the denominator. So you've got to avoid 5. You've got to avoid -1. So you need parentheses on these. So all of those need to be parentheses. You're welcome, Chloe. Okay, let's look at, for the same reason that we're not including it here, because we can't have a 0 down there. So this has got to be parentheses for the exact same reason, because it's in the denominator. Okay, let's look at the other one that I gave you. F of x equals 50 over the square root of 50 minus x. Again, this guy has both of our problems. He's in the denominator, so we know he can't equal 0, and he's under a radical, so we know he's got to be greater than 0. So what we would start out with is 50 minus, because he's in a radical, we'd say, well, he's got to be greater than or equal to 0, because I can't have a negative down there, that's not real. But then you also have to recognize he's in the denominator, just like the previous one, so we cannot let him equal 0. If we ended up with the square root of 0 down there, the square root of 0 is 0, and that's not legal. 50 divided by 0 is not allowed. You can't have 0 in the denominator. No dividing by 0. Ask your calculator to do it, and they'll say, no, domain error. So this is not correct as a setup. 50 minus x is greater than 0 is a good setup. Okay, there are lots of ways of moving this. I'm going to move the 50 over. So I get that. Nobody cares about negative x. I've got to divide by -1. I get x and 50. But whenever you divide by a negative, the inequality flips around. So we've got x is less than 50. I didn't put this problem on this review just for giggles. I put it on here for a reason, to remind you that when you divide an inequality by -1, you flip the inequality. That's a brain cell aspect that's really hard for us to remember. So I'm showing it to you now. When you go take your test, don't forget. So on the number line, we got a 50 right there. Got to be less than 50. There we go. That's the mess. So negative infinity is where this starts, goes up to 50, but don't include 50, because if you do, 50 minus 50 is 0. Square root of 0 is 0, which is not ordinarily a problem, but when it's in the denominator, that's a problem. So there's the answer right there, negative infinity to 50. Any of those numbers, anything back there will work here. Okay, let us look at 7. Got f of x is 7x plus 4, g of x is 6x squared. We're finding add them, subtract them, multiply them, and divide them, and then find the domain for each one. Okay, so let me write them over here. Let's see, this is number 8. F of x equals 7x plus 4. G of x equals 6x squared. Okay, f plus g, just take the two functions and add them together. That's 7x plus 4 plus 6x squared. On a multiple choice test, you would expect to see this guy first. So be prepared to see them rearrange them so that they have descending exponents. Let's look at f minus g. It's going to be f first, 7x plus 4, minus whatever g is, and in this case it's only one term, so I don't need to put it in parentheses. It's just one thing getting subtracted. And again, I would expect them to scoot that little guy up to the front. F times g is going to be 7x plus 4 times 6x squared. That'll give us a distributive problem, so 42x to the third plus 24x squared. Go ahead and distribute. And then f divided by g, 7x plus 4 over 6x squared. But you got to be careful here. Well, okay, we're just doing it. 7x plus 4 divided by 6x squared. There's no simplifying I can do there. Everybody doesn't have a common factor, so that's the answer. Now they asked for the domain on all of them. We're looking for denominators. We're looking for radicals. There are no denominators or radicals right here on f plus g, so the domain is negative infinity to positive infinity. There's no boogeymans there, so negative infinity to positive infinity. F times g is clean also, negative infinity to positive infinity. This is a problem though. We've got a denominator and we've got to avoid 0. If we put 0 in there, 0 squared is 0, 6 times 0 gives us 0. So you know 6x squared cannot equal 0. Divide by 6, we get cannot equal 0, take the square root, x cannot equal 0. So the domain here is going to be everything but 0. All that to the left, all that to the right, just not 0, because if you choose 0, it explodes here. Bomb goes off. So negative infinity to 0, parentheses, because you don't want to include 0. Same reason as before, Chloe. Union, infinity, or 0 to infinity. So that would be the domain here, the domain for this last one, because we had a denominator. Okay, number 9 is giving you these two. You're coming up with f composed of g. Let's see, I want to cover one other thing here on number 8. I don't know if my math lab does it well or not, but if let's say g had been 6x squared minus 4, something like that, and we were doing f minus g, then you've got f, which is 7x plus 4, then you've got minus all of g, and g is 2 different terms, so you can't just do this. That's not going to cut it. You've got to subtract both of them, and then you'll have to distribute. So if you're subtracting 2 terms, you have to be very careful that you distribute that negative over that negative. That gets so forgotten by you guys, and it's, you know, it's just a thing. You've got to remember it. Okay, number 9, f composed of g of x, g composed of f of x. These two are very difficult when you, well, more difficult. They're more difficult than when you've got a number. I don't care if you get these right, because your test will only have a number. I'm not going to ask you to do f of g or g of f of x. We're going to look at those though. So let me start a fresh page here. I don't know, I emailed you guys because your number 16 on 3.4, I didn't explain those. I rearranged and just didn't get around to explaining, didn't see it. So I did an extra recording at BBCU for you for that number 16. Okay, bye Anthony, I'll see you this afternoon. So you've got a recording for number you've got an extra recording for 3.4 number 16, and I emailed you that, and you can see it out at recordings. Okay, let's see. We've got number 9. F of x is x plus 3. G of x is 6x minus 1. So let's do f composed of g of 3 first. I want to do the numbers first. It's just easier. Go after g of 3 first. You've got to do f, which is composed of what you got for this piece. That's what you're saying. F composed of g of 3. So we'll do f, but we first have to get g of 3. So take 3 and put it into g. 6 times 3 is 18. 18 minus 1 is 17. So that part right there is a 17. Now go do f composed of 17. Grab that 17 and put it right in there. 17 plus 3 is 20. So we take our g of 3, figure out what that is, and then walk it over to the f function. Let's do the opposite of that. G composed of f of 3. Again, it's g that is composed of f, of what you got for f. So go do f of 3. So let me go find the f function and plug in a 3. 3 plus 3 gives me 6. So that back end is 6. Now I'm going to go to the g function with my 6 in my hand and plug that in. 36 minus 1, so we get a 35. Okay, let's look at f composed of g of x. You won't have this on your test. It is part of the review, and I want you to get 100 so you get the bonus point and get the 100 points and all like that. G of x, go back and look at just what g of x is. G of x is 6x minus 1. So that is 6x minus 1. We don't change it. They're just asking you to find g of x. Bam, right there. Now it says go to the f function, and everywhere you see an x, plug in 6x minus 1. So f of x itself is x plus 3. I'm being asked to go to the f function and plug in 6x minus 1. So I'm going to go 6x minus 1 and then plus 3. Clean that up. 6x plus 2 is what we get for that. Let's look at g composed of f of x. Start in the back end. Find f of x first. F of x is x plus 3. So now I'm going to take that x plus 3 and travel over to the g function. The g function is 6x minus 1. So what I'm going to do is I'm going to do 6 times, what do I have for x now? X plus 3 minus 1. Distribute and clean up. So we get 6x plus 17. I know you're not as good at that as you are with the numbers. I only gave you a number for the test. Okay, number 10 and 11, asking to find the inverse. So we start with f of x equals 6x plus 4. They tell you it's 1 to 1, and they're asking you to find an equation for the inverse function. So go through the 4 steps. The first step is to call this y. So y equals 6x plus 4. Inverse is literally swap them out. X's get up and move into the y position. Y's get up and move into the x position. So swap these two out. X equals 6y plus 4. Next step is solve for y. So I want to get y by himself. I've got to move the 6 across, and I've got to move the 4 across, and you got to do it in the right order. So I got to move the 4 first. So I get x minus 4 equals 6x. Now divide by 6. Oops, I screwed up something. 6y there. That's a y, so I put a y there. Divide by 6, and I get y equals x minus 4 over 6. And the last thing you do is acknowledge that what you've done is you found the inverse. So let's call this the inverse. F minus 1 of x gives you x minus 4 over 6. So the 4 steps, you know that f of x and y are the same thing, so give it the name y. Literally swap places, solve for y, and once you get y, put in the f of negative 1 of x, which is the way we call an inverse function. Let's do number 11, same game. F of x equals x plus 1 to the 3rd power. First thing you do is call this y, get it in terms of x and y. Second step, swap them out. We're doing the inverse. X equals y plus 1 to the 3rd power. Now we're going to spend almost the bulk of all the rest of our time in the many steps getting y by himself. So we want to isolate y. That means we're going to have to get rid of the plus 1 and the 3rd power. The first thing you need to do is get rid of the cube. So let me do the cube root there. When I cube something and uncube something, that frees him up. Whatever you do to one side, you have to do to both sides. So I get the cube root of x there. Still trying to solve for y, so I got to subtract 1. So I get the cube root of x minus 1. And now just acknowledge that you get it, that this is an inverse function. So f of negative 1 of x equals the cube root of x minus 1. And remember, this is a multiple choice test, so everything doesn't have to be perfect. I do want you to see that we were multiplying times 6 here. We're dividing by 6 here. We were adding 4 outside of this x piece. Now we're subtracting 4, and it's inside the x piece. Here we were cubing x. Now we're uncubing x. We were adding 1 within the function of x. Now we're subtracting 1 outside the function of x. So it is very much, everything is opposites. Okay, continuing on inverses, use the graph of this to draw the graph of its inverse function. Okay, I think the easiest way to do this for me, for my brain, is to set up a t-table. I'm going to look at this point, that is negative 1, 2, 3, 4, 5, 6, negative 6, negative 2. I'm going to look at this point, that's 1, negative 1. And I'm going to look at that point, 1, 2, 3, 4, 5, 4, 1, 2, 3, 5, 3. Okay, that's the function itself. The inverse is literally swap these out. So the inverse here, f of 1 of x, that's what that's supposed to say, the inverse, is just swap them out. Negative 2, negative 6, negative 1, 1, and 3, 5. So let me plot that in orange. 2, negative 6 brings me down to here. Negative 1, 1 is right there. And 3, 5 is right there. And I need to connect the dots. Something like that. It's maybe not as smooth as the other one was. And what you might notice is that we end up with a reflection across that diagonal line, that y equals x line. So the orange and the original, the inverse and the original function are reflections of each other. This point reflects over here, those 2 points reflect, and those 2 points reflect across that mirror. So that's my easiest way. I don't easily visualize that, just not the way my brain is structured. So I need to do the t-table. Number 13, given that function, find the inverse and graph both on the same system. Is that 2, negative 6? Ah, it's negative 2, negative 6. That's why it did such a funky thing. Thank you. That is a good point there. Who caught that? Amanda. Good for you. And I acknowledge that many of the rest of you may have also. So this was negative 6, negative 2. I just graphed it wrong. So on the orange, that's not a good guy. It's negative 2, negative 2, negative 6 right there. So this comes down a little more smoothly. That's wrong. And that looks a little better. Yeah, that looks good. That looks more like a reflection across that axis. Thank you, ma'am. Appreciate it. Okay, so got to be paying attention to what you're doing. Number 13, we're going to do an inverse. We're going to do kind of a combo of 10, 11, and 12. So let's see what we've got here. This is number 13. F of x equals 8x minus 6. Going to find the inverse first, like we were doing up here. So I've got y equals 8x minus 6. Swap them out. Get y by itself, solve for y. So the first thing I want to do is add 6 to both sides. Then I'm going to divide by 8. And then I'm going to acknowledge that that is actually the inverse. Okay, so we end up with that. Let's do a sloppy graph here. So the original 8x minus 6 says that what you want to do, if you're doing if you're graphing y equals mx plus b, you've got a slope of 8 over 1, and you've got a y-intercept of -6. So I'm going to go down here to -6 and start here, begin there, and then go up 8 and over 1. So it's a super steep line, something like that, because its slope is 8. I got to climb up 8 steps before I can move over 1. Very steep line. Now, when I'm finding the inverse of that, when I'm graphing the inverse of that, it needs to be reflected across there. You could graph this if you wanted to using y equals mx plus b, but that's kind of an awkward 6/8, 3/4. That's kind of an awkward y-intercept. So I think it's just easier to take the 2 points that we've got here. Let's see, that point we know is 0, -6. This point right here, I know it's not as easy with a sloppy graph, but remember I went up 8, so that's a 2, and I went over 1. So the coordinates of that point are 1, 2. And then if I'm finding the inverse, I'm going to flip those out. -6, 0, 2, 1, and with any luck I can accurately graph them. Let's see. -6, 0 is going to be over here, something like that. 2, 1, go over 2, up 1, something like that. And then this line will come in like that, being a reflection. The orange and the black are reflections of each other across the purple diagonal. Remember, you're going to have it graphed for you. Oh, something I want to be sure and tell you. Several of you had trouble seeing when TestGen, the test that you're taking, has a negative in front here. A couple of you had problems seeing that. I went and looked at your scratch paper, and if you had written it down without the negative, I gave you full credit for it if you did it right without the negative, because I get it that it's a little difficult to see a negative in front. I'm not going to cut you that slack this time. Watch for it, look for it. So be careful, because they are a little tricky to see the negatives in front of coefficients. So watch out for that. Okay, let's see. Graph both on the same system. Find domain and range. Okay, the domain for any line except a straight up vertical line is -infinity to +infinity for all of them. But the range is the same thing. So let's see if we're going to look at that. Yeah, we're going to. We're not. Okay. What they want you to see is that the domain for the orange one matches the range for the black one. Just as the way they swap out places on a t-table, on a graph, they swap out places here. So the domain for the function will always match the range of the inverse. And I know you saw that sometimes. I'm not 100% sure that you have to worry about it for your test, but that's a fact that we played with a lot, and you're seeing it here. I mean, they match, so it's hard to see that. And then the range for the function will also equal the domain for the inverse. So they swap out just like the others do. Number 14, we're looking at this parabola. Find the vertex, y-intercept, axis of symmetry, domain and range, and graph also. So the routine, I think we can do all that here except for the graphing, maybe even that. Vertex of this new one, the opposite of what's happening there, the same as what's happening there. So we've got a vertex of 2, -3. The y-intercept, whenever you see the word intercept, you know you're zeroing out the other guy. So we are going to put a 0 in for x. Let me do that. And then we're going to work it out. 0 minus 2 is -2. -2 squared is 4. 4 minus 3 is 1. So to find it, you use a 0, but most of your MyMathLab only wanted 1. They wanted the y-intercept to be 1, not 0, 1. They weren't asking for the full point. Axis of symmetry, x equals whatever the x equals. So the axis of symmetry will be a 2. The domain and range, let's look at that. Let's go ahead and graph that, sloppy graph that, and then we'll look at that. So number 14, the vertex is 2, -3. So down here somewhere, 2, -3. I know that this is a parabola because it's x squared. I know it will open up because there's no negative in front there. So it's well, let's see, we've got another point for it. We've got that the y-intercept is at 1. So I know that it's going to cross through there on its travels. So something like that is the way that will look. Something like that. Just make sure that it goes through 2, -3 and goes through 1. Those are the things you have to worry about. The axis of symmetry, x equals 2. It's just the vertical line that runs through the vertex point. Okay, we're going to do the same thing for number 15. It's a little bit more complicated because it's not gifted to you in the way that this is, where you read it straight off, opposite, same. It's written like this, and we'll look at another one here for number 16, similar to that, where it's written out in standard quadratic form. So grab number 15. Domain and range. Ah, thank you. I always forget domain and range. I know that about me. Okay, so we're back to number 14, looking at domain and range. So the domain of all parabolas that we look at is always -infinity to +infinity. There's never any, we don't have them opening up sideways. So our domains for our parabolas will always be -infinity to +infinity. You can see that because this arm will continue on using up the number line that way. This arm will continue using up the x-axis going to -infinity. Range is trickier on parabolas. You're starting at the bottom here. Start at the bottom of the thermometer. Nope, not using it up. Nope, 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 nope. There's nothing down here yet. We don't use up anything until right there. And on the y-axis, that's a -3. So you start using up the y-axis at -3, and that goes all the way on up to infinity. Thank you, Chloe. Number 15, we're doing the same thing as number 14, so be sure I cover domain and range on this one too. Let's see, we got f of x equals x squared plus 5x plus 4. In order to find the vertex for this one, remember this is the weird one. This doesn't have the set of parentheses where we get to read it straight off, and like we did a bunch of them up here where we just read it straight off. We're going to have to work on that. In order to find the vertex, you're doing -b/2a for the x coordinate, and then what they call f of -b/2a for the y coordinate, which just means take your x and plug it in. So let's work on the vertex here. -b/2a. It'll be negative, then b is a +5, 2 times a is a 1. So we're getting -5/2, -5/2. Let me make sure that's a little bit strange in our life because we didn't have, we didn't have too many fractions. You had mostly whole numbers. Your test is whole numbers. So this is a little bit trickier. You can call it -5/2 or -2.5. I see in the answers I called it -2.5. which makes me think that my math lab is doing that. So we'll just use that one. But you look, you've got your answers there. Now let's plug that in. The way to find the y coordinate is to plug in -2.5. So f of our x will be -2.5 squared, 5 times -2.5 plus 4. So -2.5 times -2.5, I think that gives you 6.25. Let me just make sure. I mean, 2 times 2 is a little bit more. Yeah, okay. 5 times 2.5, 20, 12. Okay, so we're getting minus 12.5. It's a minus 12.5 plus 4. So add this up in your calculator. Negative 6.25 plus 4. Maybe it's that. Let me peek at my cheating notes here. Number 15. Boy, my answer sheet is all over the place, isn't it? Trying to fit stuff in. Yeah, okay. So there's the y coordinate, negative 2.25. Let's start building this. We know it's a parabola, and it's going up because there's a positive. Negative 2.5, there's negative 1, negative 2, negative 3. So negative 2.5 is right in this range, and then we need to go down 2.25. So down 1, down 2, and a little bit, somewhere around in there. There's negative 2. That's going to be sitting there like that. Not much trickier than that. See, what else do we want off of here? We want the y-intercept. So whenever you're seeing the word intercept, you know you're zeroing out the other guy. So we're going to zero out the x, 0 there, 0 there, we get a 4. So 0, 4 is the y-intercept. So way up here would be a 4, and this guy's going to go like that. Okay. Next, we are looking at the axis of symmetry. It's always going to be x equals, and then it'll be the x coordinate of the vertex point, negative 2.5. So right down here, negative 2.5, and then domain and range. Domain, always negative infinity to positive infinity. Range, okay, this one's similar to the previous one in that we don't have ponytails going down. We're starting on looking at the thermometer, the y-axis, and asking ourselves, what part of the y-axis does this parabola use up? You have to start with negatives, and it's not using up negative infinity. It's not even using up negative 3. It cuts in at the thermometer right there at that y-coordinate number. So it starts using it up at negative 2.25 and goes on to infinity. Number 16. F of x equals negative 3x squared plus 12x minus 5. It asks if it has a minimum or a maximum. Okay, well, it's a parabola, and it's got a negative on it. So we know that it's going to be going, let me just draw it here. We know it's going to be going down because it's got a negative on it. So that vertex point, that's the highest the roller coaster gets. So this will definitely have a maximum, not a minimum. These don't ever have a lowest spot. They go all the way down to negative infinity. It has no minimum, has no low. It asks you to find the value and where it occurs. So the maximum value is always the y. Where it occurs is always the x. So we find the x first because that's what we do the negative b over 2a bit about. So where this maximum occurs is going to happen at, let's figure the vertex. And the vertex is going to be negative b over 2a. So I get a negative, then it's a positive 12. So I got a negative 12 in the numerator. And then 2 times a, which is a negative 3. So I get negative 12 over negative 6, which is 2. So where it occurs at x equals 2. What is the highest value? Where is that maximum? How high on the y-axis does it go? That involves putting the 2 into this equation. So f of 2 equals negative 3 times 2 squared plus 12 times 2 minus 5. 2 squared is 4. That gives us negative 12 plus 24. I'm not sure how many of you have seen that this is almost always double that one with a sign change. It happened here too. Double that one with a sign change. That's what happens. So let's see, we get 12 minus 5, which is 7. So the maximum value is 7. So that tells me that my vertex is 2, 7. Go over here, up over 2, up 7, and it's going to go down like that. So that's the maximum value. It occurs at 2. But the maximum value, how high does this get? This is the question of how high. The y-axis answers how high. So 2 is where it occurs, but how high do you go in that? You go up to 7. Okay, and that's not, well, yeah, just be sure you understand that the x is where it occurs, but how high do you go? You don't go 2, you go 7 up. So how high is a function of the y-axis. All right, number 17. They're giving you a formula for the height of a ball. Ooh, I messed that up. Right here, f of x, you need an equal sign in there. There's no doubt about that. Let me change that one. So we've got equals negative 0.2x squared plus 1.4x plus 9. We're throwing the ball and it's landing. Let's see what they ask you. Where x is the ball's horizontal distance in feet from where it was thrown. So this is horizontal distance. From where it was thrown. What's the maximum height? And how far from where it was thrown does this occur? Okay, so they're asking you for this. These are such similar problems. The maximum height, that's the same maximum value. This is a negative parabola. So you know it's doing this. It's got a maximum height. They ask you how tall does it get? That's the y function. How high does this go? And where does it occur? That's the x function. So we're going to do negative b over 2a. These are very similar problems. The 16 and 17 are. So we've got a negative positive 1.4 over 2 times negative 0.2, negative 1.4 over negative 0.4. It gives us 3.5. So the x, it occurs 3.5 feet out from where you threw it. That's occurring right here, not the maximum's right there, the maximum right there at 3.5 feet. But what is the maximum height? That's a y question. So we have to plug in 3.5. So f of 3.5 equals negative 0.2, 3.5 squared. Let me start again on that. F of 3.5 equals negative 0.2, 3.5 squared, plus 1.4 times 3.5 plus 9. So you will have something like this, and the answer to it has to do with where does it occur and its maximum height. It's only going to ask you one of those questions. So work that out, squaring this piece first to do it that way. And let's see, let me just cheat on this one. I think it's 11. Let me find that. 17, 11.5. So we're getting 11.5 feet for that math. So that means that the ball goes to the maximum height of 11.5 feet. It rises up to 11.5 feet. Where does that happen? It happens at 3.5 feet out. Okay, how far does the ball travel horizontally before hitting the ground? You won't have to know this for the test, but I can't separate out parts of questions on my math lab. What they're asking you for here is just what we did in class also. They're asking you how far out, where is this on the x-axis, where this ball hits the ground. That is happening. We don't know what the x is. That's what we're being asked to find. How far out does it happen? But we know where it happens at y. That's not raising up on the y-axis. So we are plugging in a 0 there. negative 0.2x squared plus 1.4x plus 9, and doing quadratic formula for that, because this is not going to factor cleanly. Go back in your notes, because we did this exact problem, and find out how we did that with x equals negative b plus or minus, all that routine. We came up with two answers there. Two answers. We had to reject one because one happened back here at negative on the y-axis, and the other one happened at 11.1 feet before hitting the ground. So this is not part of what you'll have to worry about for your test. You will have to worry about what the x is or what the y is. Negative b over 2a is the way we get that. All right, let's keep moving forward here. What's next? Number 18. Let me autofocus that again. Sometimes it gets kind of off. And let me do attendance here. Okay. Determine end behavior, find the intercepts, and determine symmetry, and graph it. Okay, so part of this, let me just do it all on the sheet. X to the third power minus 6x squared minus x plus 6. Okay, end behaviors. We have a cube. You know that that's a snake charmer. So this is what this behavior is going to do. It's going to rise to the left, fall to the left, rise to the right. This is falling to the left, rising to the right. I know on the answer sheet, end behaviors didn't come across. They do if you're looking at it online, but when you print it out, when I printed mine out, I get little squares here. That sometimes happens in the transition between MathType, which is the software I use, and Word and printing. So sorry about that, but I think that's not too tough for a lot of you in behaviors. The intercepts, in order to find the intercepts, we're going to have to factor this. So let's see, we've got 4 terms. We're going to look at those two. We're going to look at those two. So I'm going to pull out an x squared, get an x minus 6, bring down the negative. These don't have anything in common, so I'm putting a 1. And then I know this is going to work. That parenthesis has to match that one. Distribute to be sure. Negative x plus 6, cool, we're in business. Now that and that have an x minus 6 in common. We pick up the leftovers. This is just factoring grouping. I can still factor that. So I get x minus 6, x plus 1, x minus 1, and they're my intercepts. Translate them though. You know that this is a liar. So we're going to cross the x-axis at a positive 6. We're going to cross the x-axis at a negative 1. And we're going to cross the x-axis at a positive 1. The symmetry here. Remember, symmetry talks about looking at the exponents. If they're all even, you've got y-axis symmetry. Like a parabola has y-axis symmetry if it's sitting on the origin. If they're all odd, you've got origin symmetry where you spin the whole thing. If it's a mixture, it's just neither. So when we're looking for symmetry, looking at these exponents, 3 and a 2, that's a mixture. So this has no symmetry. No symmetry. And most of what we do will have no symmetry. Let's graph this. Let's see, we got a 6, we've got a 1, and we've got a negative 1. We know we're coming in from down here. We're going out there. All of these only cross. They don't turn around. Remember, they've got, it's one exponent, an exponent of 1. If we had a 2, then we'd be doing the turnaround thing. But each one of these has an exponent of 1. So I'm going to come in here. You know what? I could figure out what's happening here if I wanted to. If I wanted to figure out the y-intercept. In order to figure out the y-intercept, there's that word intercept. So 0 out the other guy, 0, 0, 0, 6. So this is going to cross the y-axis way up there. So it's not going to just go bubble, bubble. It's going to come screaming up here, come back cross, cross, and go out. So that's going to go way high on there. You're not going to have one that's going to have a little humpy and a big humpy, and you have to know which it was, unless they're asking you for the y-intercept. If they're asking you for the y-intercept, then you're responsible for it. Okay, number 19, doing the same thing. F of x equals negative x to the fourth plus 9x squared. Okay, in behavior, this is an even exponent, so I know that it's going to look like a parabola. Its end behaviors are. It's got a negative in front of it, so I know that it's going to fall to the left, fall to the right. Stuff's going to happen in here. Okay, that's end behaviors. Let's find the intercepts. We need to factor this. They both have an x squared in common, and you always want to pull out a negative if the leading term has a negative on him. So if I pull out the negative and I pull out x squared, I'll have x squared left over, plus, no, that'll be a minus 9 now because I'm pulling out a negative. Check it just to be sure. Negative x squared times x squared is negative x to the fourth. Negative times negative gives me a positive. X squared times 9 gives me negative 9. So we're in business. Got this still, and this will factor. X plus 3, x minus 3. So in finding the intercepts, that's going to be a 0. That's going to be a negative 3. That's going to be a positive 3. So let's graph this. 0 is one of ours. Negative 3 is one of ours, our intercepts, and so is 3. Let's see, coming in from down there, going down there. I know that 0 has an exponent of 2, so that's going to be a turnaround place. 0 will be a turnaround place. These are each exponents of 1, so they will be crossing. So I'm going to cross here. And now when I go down to 0, I need to do a turnaround. So bump it up there. And then at 3, I'm going to cross again. So I've got that kind of thing. One other thing that they're asking you to do is to determine symmetry. Let's look at our exponents. Oh, they're both even. That means that we're going to have, if we're even, we're going to have y-axis symmetry. That means that this line is the symmetrical line, and you can see that. If you flop the left-hand side over to the right-hand side, you end up with the same thing. So it has y-axis symmetry because we only have even exponents. Y-axis symmetry will give you is from even. Odd axis symmetry will give you origin. If they are all odd, let me start that again. If all of the exponents are even, you have y-axis symmetry. If all of the exponents are odd, you'll have origin symmetry. Those both begin with O. It's kind of easy way to pair those two. Okay, synthetic division. Number 20. It says x to the third plus 3x squared minus 8x plus 4 divided by x minus 1. Okay, synthetic division, that's a liar. You know it's always a liar, and we'll know it in 3.5 also when we'll do some more work with it next week. You're going to change that to its opposite number. So we're going to put a 1 over there. Anytime it's attached to an x, you're doing the opposite. Put the numbers down here, and then let's go to town. 1 times 1, 4, 1 times 4, negative 4 gets negative 4. Yay! It worked. It divided without a remainder. I mean, they always work, but you want them to divide without a remainder. That's what we're looking for. This was x to the third, so this answer that we've got will be 1 exponent down from there and then stair steps. So x squared plus 4x minus 4 is the answer. When you divide that with a 3 exponent divided by a 1 exponent, you get this x squared plus 4x minus 4. And that's all you're asked to do in that one. 21, you've got 3x to the third plus 19x squared plus 26x minus 5 over x plus 5. Okay, same game, just written a little differently. X plus 5, we're going to use minus 5 because it's attached to the x. Got a 3, 19, 26, and negative 5. Add those, multiply, add those. 6 times negative 5 gives us negative 30. So this is not going to divide without a remainder. We're going to have a remainder. Add these two up, we get negative 35. 4 times negative 20, yeah, that looks good. Okay. This was x to the third, so you know this is 3x squared plus 4x plus 6, and then minus 35 over what we were dividing by. And that's our answer. Let me just peek at that to be sure that I didn't muck that up. Lots of ways of mucking that up. 4x plus 6, good, good deal. Okay. Let's look at 22. 22 is using remainder theorem. It's still synthetic division. That's all they're asking you to do is use synthetic division. Let's see, 22 says for f of x equals 4x to the third minus 5x squared minus 3x plus 4, use synthetic division and the remainder theorem. And the remainder theorem to find f of negative 1. Okay, to be honest, you've got two ways to do this problem. You've already got to do synthetic division on the others, so you'll lose points there if you don't understand synthetic division. And come on, synthetic division is the funnest thing we've done. But what they want you to do here is to put negative 1 here and divide this out, and the remainder we get down here is what f of negative 1 is if we were to plug in a negative 1. So there are two ways of doing this. Let me show you those two ways. Let me make sure we got time. Yeah, we got time. Okay, so 4, negative 5, negative 3, and 4. Negative 4, negative 9, 9, 6, negative 6. I'm getting a negative 2. That's the answer. Negative 2 is the answer here. They're saying, oh, that's okay, Gage. Catch the rest of it if you don't understand it. So have a good time at work. I know you always do. And check the rest of the recording if you need help with the rest of these. Okay, so what that's saying is that you can solve it this way. That remainder is the answer right there. We could have gotten it a month ago. You didn't know this, but you could still have found f of negative 1 by plugging in a negative 1 there. Negative 1 cubed will give you a negative 1. 4 times negative 1 will give you a negative 4. X squared, negative 1 squared will give you 1. That's a minus 5. Negative 1 times negative 3 is a plus 3. Plus 4. Negative 9 plus 7 is negative 2. So I'm going to let you solve it either way you want to. You can plug in an f of negative 1, or you can do the remainder theorem, and that's your answer. Or do both if you want to verify it. You do that one your own way. I will not go after you to make sure you know what you're doing, because you have to do synthetic division on other problems. Okay, number 23 says solve x cubed minus 5x squared minus 22x minus 16 equals 0, given that negative 2 is a 0. So they're telling you negative 2 will work. So let's try that out. Negative 2. Notice I didn't change its sign because it's not x plus 2. It's negative. They're just telling you. There's no x associated with it. Okay, 1, negative 2, negative 7, 14, negative 8, and then we're getting 16. Yay, that's exactly what was supposed to happen. So this is x squared minus 7x minus 8 equals 0. x and x, signs need to be different. 8 times 1 will give me 8 and multiplies to give me 7. I need to get a negative 7x out of that. So if I'm going to add them together, it'll be a negative 8 and a positive 1. So we get, here it's a liar, we get a negative 1. Here it's a liar, we get an 8. So the question said, solve the equation given that negative 2 is a 0. So negative 2 is a 0, negative 1 is a 0, and 8 is a 0. Those would be the answers. 24, list all the possible zeros. Got 5x to the 4th plus blah, 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 you don't even care, minus 10. You need to worry about when you're finding all the possible rational roots, all the possible zeros, you're worried about those two numbers, p over q. So you don't even care what's happening in here. We'll never care what's happening in here. So p, the factors of p are 1, 2, 5, and 10. The factors of q are 1 and 5. So the list of possible rational zeros, all possible rational zeros will be found by going plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. We've exhausted using 1 as our denominator. Now let's go through our list and use 5 as our denominator. 1/5, 2/5, 5/5 is 1, we already have it. 10/5 is 2, we already have it. So there's our list of all the possibles. And again, it's a multiple choice test, so you know that it'll be on there. Just be careful, because if they've thrown in a 3/5 there, it's wrong. So look at the others and make sure in those little lists, in those long, complicated lists, that you have found the one you want, that the others are wrong. Number 25, n equals 4. 3i, I'm changing this problem. I'm changing it to 3i and I because I want to be sure you understand what to do when it doesn't have a constant in front of it, a coefficient in front of it. So I'm changing this problem, equals 60. Okay, we're supposed to come up with our function. So f of x equals, put an a there because there might be a number that matters. We need 4 sets of parentheses. 3i is one of our zeros, so that means it'll be x minus 3i. And anytime you have an I, an imaginary answer, you will also have his conjugate pair. And I is an answer, so x minus I will be an answer, and x plus I. Always use their conjugate pairs. Okay, so f of x equals a. I'm going to FOIL those two out. That'll give me x squared plus 9. I'm going to FOIL these two out, and I'm going to show you that foiling because I think that's a little trickier because it doesn't have a number. So x minus I, x plus I. First, remember we're going to FOIL this, but you don't have to OI it, you just have to FLOL it. So x times x gives us x squared. Negative times a positive gives us a negative. 1 times 1 gives us a 1, because you know that there's a coefficient in front of each of those. And then I times I gives us I squared. Cancel out the I squared, put a negative 1, and multiply. So we end up with x squared plus 1 when you're multiplying those two out. Now let's FOIL these two. I'm going to FOIL them in descending order. So x squared times x squared will give me x to the 4th. I've got a 1x squared and a 9x squared, so that's 10x squared. And then I've got a 9 times 1. So that's just FOILing it out, no surprises there. Let's use this piece right here, f of negative 1. So I'm plugging that in. 4th, 10x squared, 9. That f of negative 1 is the same thing as 60. So let's plug in a negative 1. Negative 1 to the 4th power will give me 1. Negative 1 squared will give me 1. So 60 equals A times 10 and 1 and 9 give me 20. Divide by 20, and I get A equals 3. Okay. And Amanda, this is that funny place where you got stuck. It was a negative something here, I remember. So what you need to do now, you're not done. Here is where you need to go, right there with your 3. Plug your 3 in right there, and then distribute. So the answer to this is f of x equals 3x to the 4th plus 30x squared plus 27. There's the answer to that problem. So it's a lot of steps. It's 60, just a random number you picked. No, Chloe, I changed the problem to f of -1 equals 60. So that's where the 60 comes from. No, that's not your bad. That's not your bad. When I shift gears on you, especially for those of you who are working them ahead of time, things happen. So I wanted to be able to show you what happens with the I's, single I, not a 4I. I wanted you to, because we didn't do that in class. It's something that, okay, an algebra student ought to be able to work their way through, but I don't want to spring it on you in a test. So I changed the review a little bit, and that's where that came from. So you're comfortable with that? Good. Good. Okay, last problem, finding all the zeros. Seems a shame to waste a piece of paper. Let me fit it in here. Let's see, finding all this. Oh, no, we're going to need some more. Yeah, not as simple as that. Okay, number 26 is a good problem. You're like Nancy Drew or the Hardy Boys on this. You got to figure out what the answers are. F of x equals x to the 3rd minus 3x squared minus 13x plus 15. You know we're going to have 3 zeros, but you don't know what they're going to be. You've got to figure out one on your own. So we know the P over Q routine, 15 and 1. So it's going to be plus or minus 1, 3, 5, and 15. I don't care so much about these guys. I'm going to go after these little bitty numbers here. So let's try a 1 and see if it will work. And there you go. So it worked. 1 is one of our answers. Let's not lose that. So that is one of our zeros. Now, come from x to the 3rd power, we've got x squared minus 2x minus 15 that we are dealing with. We don't have to continue doing that. We can continue to try numbers in synthetic division, but we have a quicker way of determining the answers when it gets down to x squared. Let's use our quicker way. Plus or minus 15 will be 5 times 3. In order to get a -2 out of that, it needs to be a -5 and a +3. And then use your smarts. You know the x plus 3 equals 0. X is -3. X is 5. So don't forget our 1. They're the 3 x's, the 3 x-intercepts, the 3 zeros, the 3 solutions for this problem. Okie doke. I think we're done there. Your test is posted. Something else I wanted to remind you of. We are changing the method of how you register. If you are registering for summer, you got to worry about that by the end of March. March 22nd, I think, is the first day. That's the Monday we get back, Tuesday we get back, maybe Monday that we get back from spring break. You can register for summer. It's a new registration system, and on my current slide, this week's slide, I put a 7-minute video for you to look at the process of that. If you are not signing up for classes till the fall, I would strongly recommend you download that onto your computer, that video, so that when you do need it, you'll have it available easily to you to figure out how to register. It's I don't know, it's not self-intuitive to me, or it's not intuitive to me. I had a little bit of trouble struggling through it. It's only 7 minutes long, and it might be useful to you. You will sign up for fall, I hope. Good, Ashish, I found it useful. I hope that you will sign up for fall before Blackboard ends. Our class, each class ends at the end of the class, you no longer are able to get into our, let me start over. Once this class ends in May, you will no longer be able to have access to those slides, to anything on my Blackboard. So I want you to be sure that you've got information about it. So that's why I'm advising you to download it. I hope that you have signed up for fall classes before May, before our class ends. You'll have access to that in April, and we'll talk about it then if you have to take other classes or other math classes. But I hope you'll have signed up for it. You wait too long in the summer, and the good teachers of classes that are popular will be gone. So we'll talk about it as it opens up for fall. But for right now, anyway, download that YouTube video. It's a 7-minute YouTube video. And no, I don't teach any other classes. I think I'm happy with college algebra. But you're funny. But I will help you find teachers, though, because I know these people. I used to see them every day. And I can push you into good teachers. There's some really good instructors. And when the schedule opens up, let me know what you're taking, and I will tell you who's good. I don't think we'll be online in the fall, so you don't have the whole, unless you want to drive all over Fort Worth. But you'll want to concentrate on the campus you're closest to. Oh, you're so sweet. I appreciate that so much, Chloe. I really do. But there are lots of really good teachers. I mean, I can think of so many that are really wonderful. And I've sent students to them, and students write me back and tell me, those are good teachers that you sent me to, kind of stuff. So things will work out. So anyway, I think I'm done. I'm going to stop recording.